Hello friends, welcome you all to my YouTube channel. So guys, you all know that we will be discussing here in our discussions many concepts related to your JEE. So previous session also we have had many discussions and also we have solved some problems, right? So which are related to your matrices part, which is very familiar to appear in your JEE examinations. So today's session, let us begin with some different set of problems which are also very familiar in your JEE and other board examinations also, right? So let's start today's session with this example. So what they have given here is, if A of theta is sin theta, I cos theta and sin theta, then which of the following is not true? First one is A theta inverse is equal to A of pi minus theta. A theta plus A of pi plus theta is a null matrix. A of theta is invertible for all theta belonging to R. A of theta inverse is equal to A of minus theta. Okay, so these are the four options. Here our job is to find which is not true. It is not that we should find which is true, right? Our job is not to find which one is true. Our job is to find which one is not true. Okay, and A of theta, he might have also given as A. What is the difference between A and A of theta? Right? A means is a general abbreviation. A of theta means it specifically denotes that the given function is a given equation or any polynomial or any condition is function of theta. Right? Here you can see only theta is there. Sin theta, I cos theta and sin theta. Everything is in terms of theta because A is the function of theta. Okay, so then we should check that which one of this is not true. Okay. A of theta is given as sin theta, I cos theta, sin theta. Okay, so now what is determinant A? Determinant of A of theta is equal to determinant of this, that is sin theta, I cos theta, sin theta. Right? So I can calculate A of theta. This is determinant of A of theta. This is sin square theta minus I square cos square theta. A of theta is equal to, what is I square? Value of I square is minus 1. So here sin square minus of minus 1 into cos square theta. That becomes sin square theta plus cos square theta. That is nothing but 1. Right? So we got the determinant value of A of theta, that is this particular function, as 1. Right? So it is not 0. Make it clear. It is not 0. We got the value as 1. Okay? When it is not clear, when it is clear that it is not 0, that means it is not a the value of determinant is not 0, right? Then there is a hope that the matrix may be having inverse, right? This matrix may have inverse. Why? Because if the determinant of any matrix is not 0, right, then only there exists some inverse of that particular matrix. But now, right now we are not sure, but we can say that there may exist the inverse for this particular matrix. Okay, so leave it aside. Here, what is A of pi plus theta? A of theta is sin theta. Now what will be A of pi plus theta? This is sin of pi plus theta, I cos pi plus theta. Then here also I cos pi plus theta, and here this is theta, sin of pi plus theta. Right? So this is a function of pi plus theta. Then here, what is sin of pi plus theta? What is sin of pi plus theta? That is minus sin theta. Sin of pi plus theta is minus sin theta. Similarly, cos of pi plus theta is minus pi theta. Cos of pi plus theta is also minus cos theta. Okay, so I can write a of pi plus theta as equal to, okay, sine of minus sine of theta minus I cos of pi plus, sorry, I cos of theta minus I cos theta minus sin theta. So minus can be taken out. If minus is taken out, entire thing becomes plus. This is sin theta, I cos theta and sin theta. What is that? Once again a of theta. So this can be written as minus a of theta. Right? A of pi plus theta is what? Minus of a theta. Okay. So now you see, this is what? A of theta. And what is a of pi plus theta? That is minus a of theta. So if we add a of theta and a of pi plus theta, right? A of theta plus a of pi plus theta, as we have in this option, right? So a of theta plus a of pi plus theta will be a of theta plus minus a theta. That is a of theta minus a of theta. Both will cancel. So what will remain? A null matrix. Both will cancel with each other. What remains is null matrix. So this one is also true. This one is true. So you should go on marking whichever option you get. That is true. Right? So this will not be our choice. We should find the wrong one. Okay? So now, what is adjoint of a of theta? Adjoint of a of theta. See, a of theta is this one. What was the trick to find adjoint for a 2 cross 2 matrix? Interchange these two elements. Interchange these two elements and reverse the sign of other elements. Here also sin theta is there. Here also sin theta is there. So that will remain unaffected. This sin theta is going here. This sin theta is coming here. So it will be once again sin theta and sin theta only. And here I cos theta we are having. Both are positive. So both will become negative. Okay, both are becoming negative. So adjoint of a of theta is what? Sin theta minus I cos theta and sin theta. So now what is a theta whole inverse? A of theta inverse. So a inverse is taken as 1 upon determinant a into adjoint a. So similarly this can be taken as 1 upon determinant of a of theta into adjoint of a of theta. Okay, why? Because a inverse is equal to 1 upon determinant a into adjoint a. Right? So now a of theta inverse 1 upon determinant a of theta. What is determinant of a of theta? There is 1. So this entire thing becomes 1 and this will be adjoint of a of theta. Only thing what remains in the right hand side is adjoint of a of theta. What is the adjoint of a of theta? This is sin theta minus I cos theta minus I cos theta and here sin theta. Right? So sin theta minus I cos theta minus I cos theta and sin theta. Okay. So now sin theta can be written as sine of pi minus theta. Sin theta can be written as what? Sine of pi minus theta. Okay. And cos theta also can be written, sin theta can be written as minus of sine pi minus theta. Here what we have written? Sin theta as sine of pi plus theta. Right? Here sine of pi plus theta, we have written it as minus sine theta. Right? So what is sine A sine B? That is sine A cos B plus cos A sine B. Similarly, I can write sine of theta as, right, sine of minus Sine of pi minus theta. Sine theta can be written as sine of pi minus theta. So A of theta inverse can be written as sine of pi minus theta. Okay. And cos of theta can also be written as cos of pi minus theta. Right. So cos of pi minus theta. So what happens here? There is cos theta can be written as minus cos of pi minus theta. So that becomes minus and minus cancels. I as it is cos of pi minus theta. Okay. And then here minus I, minus and minus cancels, cos of pi minus theta, and here sine of pi minus theta. This is how it can be written. Okay. So this is how it has to be written. Okay. So now this sine of pi minus theta, cos of pi minus theta, cos of pi minus theta, and sine of pi minus theta. So this is nothing but sine of A of theta whole inverse is nothing but, I can write it as A of pi minus theta. Right? A theta whole inverse is A of pi minus theta. Now you can see A theta inverse we got it as A of pi minus theta. So here that is true. Okay. And as A of theta inverse we have some value, so it exists. This is also true. This exists, so it is also true. So which is not true then? A of theta inverse they have given it as A of minus theta. But here what we have got? A of theta inverse they have given it as, we have got it as A of pi minus theta. Okay. So this is not true. So this should be our answer. Right? This is false. This is not true. So it is false. So that should be our selection. I hope this is clear. So you have to make a note of this. So if you feel like it's good like taking it down, so pause a moment, have a look at this, right? Then make a note of this. Okay friends, I hope you have understood the previous problem. Let's take up one more example. So what they have given here is, if A is a 3 cross 3 skew symmetric matrix, if A is a 3 cross 3 skew symmetric matrix, then trace of A is equal to. So friends, whatever we are solving here, all are different types, right? So you can see that, you can feel it. If A is a 3 cross 3 skew symmetric matrix, then trace of A is equal to. Options are given as -1, 1, determinant A, and none of these. Okay. Coming to its solution part, how to approach this one. A is a skew symmetric matrix. It is given. Then A transpose will be equal to -A. So we know the property of skew symmetric matrix. A transpose is equal to -A. And what will be the diagonal elements of any skew symmetric matrix? That is A11, A22 and A33. A11, A22, A23. What will be the value in skew symmetric matrix? All diagonal elements, all the elements in the principal diagonal will be 0. That is one more condition for skew symmetric matrix. If you check any skew symmetric matrix, the principal diagonal elements will be 0. So I can write, and AII is equal to 0. AII is equal to 0. Right? So this is the condition for skew symmetric matrix. Now coming to its trace. If A is a skew symmetric matrix, AII will be equal to 0. Right? So what is trace? Definition of trace: sum of all elements in the principal diagonal. So when all the elements are 0, what will be their sum? Definitely 0. Right? So I can write trace of A as equal to 0. So what we got the answer? Trace of A as 0. So when you reach this point, right, so you decide the answer as 0. But is 0 given in your options? No, it's not given. So directly which you are going to select is this one. None of this. But this is wrong. Right? This is entirely wrong. You should not go for this. At this point you should not go for this conclusion. Right? So trace of A, definitely we got it as 0. And 0 is not there, so I am selecting none of this. That should not be there. Right? You should think a while. Okay? So now I can also write determinant of A as equal to determinant of A transpose. Determinant of A as equal to determinant of A transpose. Right? Why? Because A is a skew symmetric matrix. Okay? Now, what is A transpose? Minus A. So you consider this as 1. Now A transpose is minus A. I will write it as minus A. Instead of this A transpose, I am going to write it as minus A. Now, I have given a note, right? Determinant of K into A is equal to K to the power n into determinant A, okay, where n is order. N is order of the given matrix, right? So determinant of K into A is what? K to the power n into determinant A, where n is the order of the matrix. Here what is the order? Order is 3. That's 3 cross 3. So value of n will be 3. And what is K here? If I compare this and this matrix, what is K? K is minus 1 here. K is what? It is minus 1. Right? So this can be written as minus 1 into A. So I can consider K as equal to minus 1. Right? So if I compare this to this one, I can write this as K will come out. So K is minus 1. So minus 1 will come out. K should be to the power of n. Right? K is to the power of n. What is n? Here n is 3. Given the order as 3. So it will be 3 into determinant A. So I will write this determinant A as end results as equal to minus 1 whole cube is minus 1. So it will be minus of determinant A. If this shifts on the other side, determinant A plus determinant A is equal to 0. 2 times of determinant A as equal to 0. So I can write determinant A as equal to 0. Make it as equation 2. So now you compare. What is equation 1? Trace of A is 0. What is equation 2? Determinant A is equal to 0. Right? So in comparing 1 and 2, I will write trace of A as equal to determinant A. Right? So this is our right answer, not this one. Okay, what is trace here? Trace of that particular matrix is nothing but it is equal to its own determinant. Right? So you always remember this is an identity. You can also think it as an identity. If A is a skew symmetric matrix of odd order, right? What is that odd order? N should be 1, 3, 5, like that. Then trace of A will be equal to its determinant. Trace of A will be equal to its determinant. Is that clear? Or else it will be 0. So this is how you need to evaluate the things. You need to analyze the things and you need to solve the problems. So now take a moment, pause the video and make a note of this. Friends, let's continue with the last problem. This is going to be the last problem of this session. Right? Let's see how to do it. Consider matrix A such that A square is equal to 2A minus I, where I is the identity matrix. Then for n greater than equal to, what is A to the power n? So what they are saying is, consider the matrix A such that, what is the condition? A square is equal to 2A minus I. And what is I there? Identity matrix. Then for n greater than 2, here n is not the order, n is power of A. For n greater than 2, right? what is a to the power n. Okay, so what is given? A square is equal to 2a minus I, and I can write a cube as equal to a into a square. A cube can be written as a into a square, right? So this is a into, what is a square? 2a minus I. So this is nothing but 2a square minus ai. 2a square minus ai. Okay. What is 2a square minus ai? A square is 2a minus I. Minus a into I can be taken as a, right? Okay, a into I can be taken as a. So this can be written as 4a minus I minus a. So a cube can be written as, what is 4a minus a? 3a. 3a minus I, right? Similarly, a to the power 4 can be written as a into a cube. A into a cube. A into, what is a cube? 3a minus I, right? So a cube is what? 3a minus I. Okay. So this is 3a square minus ai. There is nothing but 3 into, what is a square? 2a minus I. Minus a into I can be taken as a. Okay. So this is nothing but 6a, right? Okay. 6a minus 3i minus a, right? So I is what? A cube is what? 3a minus, let's check it. So this is 2i. 2i. So this will be 3a minus 2i, right? And here also we have it as 3a minus 2i, and here a into 3a is 3a square minus 2ai, right? So 2ai is nothing but equal to 2a only, right? So now 6a minus 3i minus 2a minus 2a. So this, right, a to the power 4 equals what? 6a minus 2a is 4a minus 3i. Okay, so you compare this is take it as 1, 2, right? So in 1 what we are having? A cube, right? Or you take this as 1, 2 and this as 3, right? So equation 1 was what? A square. What we are having here? 2a minus I. So you can see here coefficient of a is equal to power of a here. Here a square is there. Here I am having, here a to the power 2 is there. Here also 2 we are having coefficient of a. And here 2 minus 1 less than 1. 1 less than the power, right? Minus I. Here a cube is there, right? Coefficient of a will be this 3. And here coefficient of I will be 1 less than 3. That is 2. A to the power 4. Coefficient of a will be exactly 4. And coefficient of I is what? 1 less than 4. Okay. So similarly if I write, I can write a to the power n as n into a minus n minus 1 into I. N into a, right? the power here, coefficient will be power, coefficient of A will be power whatever is there here, so NA, and what will be coefficient of I? 1 less than this power, so n minus 1. So if you take a to the power 5, what we will get? Same thing, 5a minus 4i. A to the power 6 if you take, so definitely you will get 6a minus 5i. So similarly if you proceed, a to the power n will be n a minus n minus 1 into I. So which is the right one? Option C. So this was the last problem, and this is how it has to be solved. So in this session we have solved 3 problems which are totally different, right? So if you know the concepts, you can solve it within 1.5 minute each problem, right? But if you don't know the concept, then it will become really difficult, right? So go through my problems, my videos daily, regularly, then it will be easy for you people to understand the concepts, right? So here we are going to stop the video for today, and for next session we are going to start up with some more new different types of problems. Okay, till then keep trying the different problems from different books, right? So whatever you get the doubt, if you get doubt in any problem, if you get stuck anywhere, directly you can discuss the doubt in the comment section. Directly you can type the question in my comment box. Definitely I'll get back to you. Okay, so the question may be belonging to any state CET, right, or any NCERT books, any corner, or JEE, any books, problem from any book of JEE, you can message me that one, right? Definitely I'll get back to you. Okay, so we'll stop the video here. Till then, keep trying. Take care.